Hey, 8th period. I hope you all decided to come to class, even though I told you I wasn't going to be here. And I hope you're treating the sub well, being nice. Today we're going to talk about the interior angles of a polygon. The objective is for you to determine the measure of the interior angles of a polygon. So first of all, what is a polygon? Rather than you sit and let me write it, I'm going to just tell you, and then you can copy it onto your paper. So a polygon is a plane figure with at least 3 straight sides and angles. So let me put a little picture here. This is not a polygon right here. There's not 3 sides or 3 angles. Neither is this. A triangle is a polygon. A kite, diamond, square, anything like that is a polygon. It has straight sides and it has 4 sides on that one and 4 angles. Also, this is a polygon. All the sides are straight and there are more than 3. That's the definition of a polygon. Okay, a regular polygon is a polygon that is equiangular, that's a hard word to say, and equilateral. So equiangular means that all the angles are the same, and equilateral means that all the sides are the same. So if we look at these pictures right here, we've got a triangle with all 3 sides that are the same, and all, I was pointing to the angles when I said that. All 3 sides are the same, and all 3 angles are the same. Same with a square. It's the definition of a square, right? All the sides are the same length, all the angles are 90 degrees. What about a stop sign? That's an octagon, and it's a regular polygon because it fits the same example and the same definition. All the sides are the same. As you can see, I marked them all congruent, even though I did this with my freehand, so it's not very accurate. However, pretend it is. And then all the angles are the same on an octagon. So those are called regular polygons. Okay. So, determine the sum of the interior angles of a pentagon. Those of you that can't remember what a pentagon is, it says in parentheses a 5-sided polygon. So I'm going to give you just a second to do that. So go ahead and do that. Don't cheat and look up at my paper. Do it on your own. Brandon, I know you did. Draw a pentagon. Then draw all possible diagonals using only one vertex of the polygon. Try to read those instructions again and see if you understand what that means. Hey, your pentagon might not look like mine. It could look a little bit differently. It could look like the sides are more even. All we needed to do was do a 5-sided shape, 5-sided polygon. The next part says pick one vertex. Remember, a vertex is where 2 lines come together, and draw all the diagonals. So that means I can draw a line to there, and I can draw a line to there. Are there any other diagonals that I can draw? If I drew here, I already have a line going there. If I draw here, I already have a line going there. So those are all the diagonals. How many triangles are formed? Well, we can count. 1, 2, 3 triangles are formed. So I'm going to put 3 right there. The sum of the interior angles of one triangle, now come on, we know this. This was in chapter 3, I think, where we talked about the sum of the angles. What are they? Shout them out. Let's hear it. I can hear you all the way in St. George. Good job. 180. Nice job. Since a pentagon has 3 triangles, the sum of all the interior angles in a pentagon is, well, how would we find that? What are we going to do to figure that out? There's 3 triangles, and each of them has 180 degrees. We're just going to go, show you my calculator here if you can see it. 180 times 3. we get 540. Okay? So a pentagon has 540 degrees. What that means is that if I add every angle, so this angle, plus this angle, plus this angle, plus this angle, plus that angle, it's going to add up to be 540 degrees. Alright, let's look at another one. Determine the sum of the interior angles of a hexagon. That's a 6-sided polygon. So go ahead and draw one. I want you to just do it freehand. Everybody draw a 6-sided polygon on your own paper. And while you're doing that, I'll check to see if I got any new text messages. Nope, nobody loves me. Alright, I guess I'll draw a hexagon. Okay, now do all the sides have to be equal? No, they don't. It can just be 6-sided polygon. Alright, same thing. We're going to pick a vertex and we're going to draw all the diagonals. I'm going to pick this one. If you picked a different one, it doesn't matter. It'll still work out. Draw a diagonal there, a diagonal there, a diagonal there. Alright, how many triangles do we have? 1, 2, 3, 4. Put our answer right there. The sum of the interior angles of one triangle, we're going to ask you again just because we love to keep asking you to see if you understand. 180 degrees. This question will never go away. Start memorizing it if you haven't. Since a hexagon has, how many triangles? 4. The sum of all the interior angles of a hexagon, well, I'm just going to get my calculator again. So it's a little quicker, and go 180 times 4. I get 720. Are you starting to see a pattern here? I hope so. If not, I'm going to give you plenty of practice. Don't worry. Flip your notes to the next page. When I said plenty of practice, I wasn't kidding, right? Alright, let's go through and pick the number of sides that a triangle has. Well, triangle has 3 sides. We know that. We figured out if we draw a triangle, grab my little scratch paper here, 3-sided figure. How many triangles are in a triangle? There's just one. I can't connect this to any other vertex because if I go there, it's already a side, and if I go there, it's already a side. So there's one triangle in one triangle. The sum of the interior angles, this is that question again we keep asking, is 180. Quadrilateral, that's a 4-sided polygon. How many triangles are in a quadrilateral? If I go back to my little scratch paper here and I draw a 4-sided polygon, I draw a diagonal and I got 1, 2. So I can put that right here. There's 2 triangles. The sum of the interior angles, so if there's 2 triangles, I have to times 180 by 2, and I get 360. Okay, a pentagon. That's the one we just did. And what did we find out? It had 5 sides. If we go back to our notes on our pentagon, it had 3 triangles that were formed. If I take 3 times 180, I get 540. Okay, hexagon is 6. Now there's a pattern that's emerging. The triangles is 4. I take 4 times 180, and I get 720. Okay, I'm going to give you a second to finish the chart, and then we'll talk about it. While you're finishing the chart, I'm going to do it secretively off to the side so you can't cheat. By the way, you guys asked for me to be funny on here, but it's really hard when you're sitting in a room by yourself. Seriously. If People keep walking by, wondering what the heck I'm doing. Just talking to myself. Did anybody beat me? Are you already done? Did I win? I'm pretty fast. Alright, check your answer with mine. Your answers, I should say. So a heptagon is what we say for a 7-sided figure. The number of triangles is 5, and I take the number of triangles times 180, and I got 900. Okay? Same with an octagon. Has 8 sides, 6 triangles. The sum is 180, or 1080, excuse me. Nonagon is 9 sides, creates 7 triangles, so the sum is 1260. A decagon is 10, number of triangles is 8, sum is 1440. Notice how when they give us how many sides there are from the figure, we're going to subtract 2 from that number and then times that number by 180. So there's kind of a pattern that we're following. So if I have n, an unknown number of sides, what would I do to n to find the number of triangles? It's going to be the same pattern. What did I do to 3? I subtracted 2 and I got 1. What did I do to 7? I subtracted 2 and I got 5. So what am I going to do to n? Can I subtract 2 from n? Yes, I can. I'm going to write it just like this. N minus 2. And then, when I'm in this column right here, what did I do to get the sum? I multiplied that number by 180. So, if we went to 6, I took 6 times 180 and I got 1080. So I have n minus 2. I'm going to do the same thing. I'm just going to times it by 180. 180 times n minus 2. And I just figured out how to find the sum of the interior angles of any polygon if I know the length of the sides. Or not the length, the number of sides. Excuse me. So n stands for the number of sides in this equation. So if we practice that, find the sum of the measures of the interior angles of each of the following. Well, I'm going to subtract 2 from 14 and times it by 180. So that gives me 12 times 180. That gives me, you should do it on your calculator at the same time that I am, 2160. That means if I have a 14-sided figure and I added all the angle measures up all the way around 14 times, they have to add up to 2160. If I have a 25gon, I'm going to take 23 times 180. And I get 4140. All right, try the next one on your own. La-di-da. Alright, this is as long as I can wait. Alright, 30 times 180. It's going to give me a pretty big number, 5,400 degrees. If I add all the angles up in a 32-sided polygon, they're going to add up to 5,400. Okay. Now this one says, find the value of x in the figures below. Now I want you to think about this without me just giving you the answers, because during class I wouldn't just give you the answers. I'd ask you to brainstorm. So I want you to, even though it feels awkward because I'm telling you from a video, to turn to your neighbor and tell them how you think you can solve this problem. I know there's a substitute here, and I'm going to have them check if you're really doing this. So do it. Turn to your neighbor. Tell them how you think you're going to solve this problem. Okay, hopefully y'all did it. If we have a four-sided figure, if we have to cheat and look back up at our chart, if we have four sides, remember that the number of triangles is going to be 2 less, and I times that by 180. So all of these numbers should add up to 2 times 180, which is 360. That means that x plus 108 plus 121 plus 59 has to add up to 360. So I can find out what my missing x is by setting up my equation just like so. And I can solve for x. Go ahead, solve for x. Okay. Combine the terms on the same side. 108 plus 121 plus 59 gives me 288. X plus 288 equals 360. So I subtract 288 from both sides. X equals 72. That's my missing angle. So now when we know 3 angles of a four-sided polygon, we know how to find the missing angle. This is just like how we solved for triangles back in the other chapters, but this time we have to actually figure out first what they're all supposed to add up to be first. So if we do a 5-sided figure like this one, and if you don't believe me, you can count them. Just trying to save us a little time, so I counted them before. We have to take 3 times 180 because we have to subtract 2 from 5. Just like we did up here in our chart. 5-sided figure is 3 times 180 and gives us 540. So 3 times 180 equals 540. Okay, now we're going to do the same thing we did over here. We have to add all of these angle measures up and set it equal to 540. Is this an angle measure? Yes, 100. That's easy to see. What about 2x plus 40? Yes. Okay. I think that says plus. My eyes are getting old, but I do think that's 2x plus 40. We're going to say it is, even if you disagree, because no one is here today to argue with me. So x plus 100 plus 2x plus 40 plus 2x plus 3x equals, I'm running out of room here, but I'll write really small, 540. All right, let's get all of our x's together. X plus 2x is 3x, plus 2x is 5x, plus 3x is 8x. 100 plus 40 is 140, so 8x plus 140, forgot my 1, equals 540. Skipping a couple steps here, 8x equals 400. So I divide both sides by 8 and I get 50. Okay. If you guys got lost on this from here to here, I just subtracted 140 from both sides. All right. The sum of the measure of the interior angles of a polygon is given. Determine the number of sides. All right, how are we going to do it backwards now? This is asking us to work backwards. I want you to turn to your neighbor and tell me what you would do going backwards from this step. I should have said from this step, sorry. If I had to go backwards. Well, up here I would first divide by 180 and then add 2. But if we look at our formula, 180 times n minus 2, that gives me 1620. So if I'm trying to get n by itself, the first thing I'm going to do is divide both sides by 180 and I get n minus 2 equals 1620 divided by 180 is 9. And then I'm going to add 2 to both sides. Some people work better by knowing the formula. Some people work better just intuitively knowing I divide by 180 and add 2. So I'll do that one this way. 2,700, if I'm working backwards, I got to divide by 180, and I get 15. And then I have to add 2 to that. So that's 17. Okay, I'm one that likes to have a formula, and I like to write it down. Oh, lost the screen. Don't worry, you didn't get out of the notes. Still going. 180 times n minus 2, because n tells me the number of sides, and that's what I'm looking for, right? It says determine the number of sides. So if n is the number of sides, I can use this formula. This formula equals the sum, so if it tells me the sum already, I can just put that on this side. So I'm going to divide both sides by 180. I get n minus 2 equals 1,080 divided by 180 is 6. Add 2 to both sides. N equals 8. Okay, last two. For each regular polygon, calculate the measure of each of its interior angles. So remember at the very beginning when we said what a regular polygon was? That every angle and every side is the same length. So how are we going to figure this out? I want you to think for a minute before I tell you the answer. Maybe I can give you a hint. Does it help to find what the sum of all of them has to equal? And then we know there's 8 of them and they're all the same measure. How would I find the sum of all the angles of an 8-sided figure? If we come up here, that's exactly what we were doing right here, wasn't it? The sum of the interior angles of a polygon is right there. So if I come down here, I have to take 180 times n minus 2. Well, my n is 8. Okay, so 180 times 8 minus 2 is the same as 180 times 6. Okay, 180 times 6 is 1,080. Okay, and that number means if I add this angle plus 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 this angle, they're all going to add up to 1,080. Now there's a trick because there's 8 angles and they're all the same measure. That's what regular polygon's telling me. Right? So I can divide 1,080 by 8 to figure out what each one is. 1,080 divided by 8 gives me 135 degrees. So every one of those angles is 135 degrees. Let's try the same with a 9-sided figure. So I'm going to have 180 times 7, right? Kind of took a shortcut there, equals 1,260. There's 9 angles, so I get to divide them up equally. So if I divide this by 9, 1,260 divided by 9 is 140 degrees. Okay, that's it for the notes today. So you guys know your assignment. It's in your yellow book, section 7.4. And that is due the next time you come to class. These notes will also be posted on the Facebook and YouTube page if you need to look at them again over the weekend. So have a great weekend.